Hello guys, I have something very important to share with you, and it is very simple. Stop relying on these things. Now I know for many of you, when a project is released without the help of the checker, you are unable to tell if what you have written is correct or wrong. But you need to understand that in the real world, as a software engineer, you are not going to have this to be able to check if your code is correct or wrong. You need to learn how to check your code on your own. And the way to do that is actually simple, and it is hidden right here in every project that is released. And this is what I'm going to show you in this video. Okay, wonderful. So what we are going to do is that we are going to try this on 3 projects. A project on Shell, a project on C programming, and another project on Python, so that we know how to go about it for all such cases. Alright, the secret to checking your code without the checker is found in these gray boxes that are always attached to the project. Now for every task that is released, you're going to see these gray boxes that are attached to them, and that is how you can check your code without the checker. Let's try it on this first project. Okay, that says that write a script that prints hello world followed by a new line to the standard output. Now the file that they expect for us to use for this project is 0 hello world. So I'm just going to copy that file, go straight into my terminal, and I'm going to VI the name of this file. Now I expect that you are just going to cd into your directory, into your repo, all that. Alright, so I'm just going to VI the name of this file, and then let's start working on it. Because we are writing a script, then as usual we are going to bring our shebang. So let's bring our shebang. Then the way to write a script that prints hello world is simply to echo hello world. It's very simple. In quotation marks, just as we see it in the task. Alright, so I'm just going to exit out of here. Wonderful. So let me ls and let's see the files that we have in here. The file that we just created, 0 hello world, is in here. Now because it's a script, before you execute it, remember that you need to change it to an executable file. And the way to do that is to change the mode and add the executable permission to the file. So the name of the file, change mode u+x, and the name of the file to change it to an executable file. Very simple. Then what we are done, we are now going to execute this file, and then we're going to find out if the code that we wrote is correct. The way to do that is to use /. This is how you execute your file, and then you bring the name of the file. Now when I enter, see what happens. You see this hello world. Hello world. So this is the output of our program. Without using the checker, we have been able to check if the code that we wrote is correct or wrong. Now if you go into your internet, you're going to realize that this is the same output that we were expecting. Then you can even go ahead and do further checks, just like you are given in the internet. So I'm just going to copy this, go back into my terminal, clear my screen, and I'm going to paste this text. What this -e flag does for the cat command is that it lets you see the last line command, the new line command. So when I enter this, you're going to see a $sign at the end of hello world, and that is the same thing that we see right here in the intranet. So you see that this is the output. So whenever you receive a project, these gray boxes that you see here are actually the way that you are going to check your program without the checker. Now if you push this code to your GitHub and check it, you are definitely going to have the correct output. So let's go and try this on a C programming project to see how that too works. Now for the C tasks, they're a bit more technical, so I need you to pay particular attention here. Alright, let's go and look for one of the projects to solve, one with an output which is more pronounced. Okay, so let's see. Let's solve this one because its output is more pronounced. When we check our code and we see the output, it will be easier to recognize what we have done. Wonderful. So this task says that write a function that prints 10 times the number from 0 to 14 followed by a new line. This is a prototype of the function. We are only allowed to use putchar, and then when we run the code, this is what we are supposed to get. Now my focus here is not really the code that's supposed to produce this output. My focus is to show you how to check your code after you have written the solution to the function, and that is very simple. So what we are going to do is that let's just try and create this file, put in the code, and then I'll teach you how to check without relying on the checker. Okay, now for this project, the directory we are supposed to be working in is this. All right, I've already created a directory for it, so I'm just going to VI the name of this file. go into it. Then I'm just quickly going to paste in the code for this task. Wonderful. So I just put in the code that solves this particular task. I'm going to save and exit out of here. Let's ls and see the files we have in here. This is the file we just created. But remember that for all ALX projects, the prototype of our function are supposed to be in the main.h file. It's always a requirement. So let's just go through the motions of those requirements and then we'll learn how to check our code. So I'm just going to vi main.h. Then in here goes the prototype of our function. Wonderful. But before that, we need to include an inclusion guard. Wonderful. So what I just did here was that I included a prototype of the function that we just wrote, and all these you see over here are just comments, and this is the inclusion guard that I included in my function. Very simple. And this is also an inclusion guard. So the main focus here is that we needed to put the prototype of our function in the main.h file, and that is a requirement. So let me exit and save. And then one more thing, remember that for ALX we are not allowed to use the standard input and output.h header file, for which reason we have to create our own putchar function that we can use to output text to the standard output, meaning that we have to create our putchar.c file. So let's do that and then we'll check our code. All these are just the requirements. We are going through the motions, and usually ALX will provide the putchar function for you. When you come into the requirements, you're going to see the putchar file right here. So you see, we are supposed to create a file called putchar.c. We'll just copy it under underscore putchar.c. We're going to vi the name of this file, and then the content of this function is going to be found right here. When you click on this putchar you see over here in the requirement, it will bring you to the ALX resources repository. You're going to copy your putchar function. You're just going to paste it in your putchar.c file. And it's as simple as that. You have created your own putchar function. Great. So now let me ls and let me see the files we have in here. We have our c source file, we have our putchar.c file, then we have our main.h file that contains the prototypes of our function. Lovely. So now let me clear my screen. How do we check if the code that we have written in our main c source code file is correct? And that is what we are going to learn right now. Let's go into our intranet and I'm going to teach you something. Now, whenever you come to the task, you are going to see that gray box that I've been talking about. So this is a file we're trying to solve. Now, if you look into this gray box, you're going to see some interesting things here. The first thing you're going to see is this Julian at Ubuntu. It is nothing. It's simply the username of the currently logged in user for this gray box. So for example, in my terminal, my username is moonspeed. All right. But for this terminal, the username is Julian at Ubuntu. So this gray box you see over here with all these things in there is simply the interface of a terminal that is being shown to you. It is very simple. All right. So this is the username of the currently logged in user. Then you're also going to see cat and then the name of a certain file. This cat you see over here is simply a shell command. It means what it does is that it helps display the content of a file. Now, this simply means that all what you see over here is simply the content of the file 5main.c that you see over here. So this cat command is listing the content of this file 5main.c. I hope that is very clear. So what you need to do is to go and create your own 5main.c file, which you are going to use to test the function that you just wrote. It's very simple, very simple. So I'm going to copy the name of this file, go back into my terminal, and then I'm going to vi the name of that file. Wonderful. Then I'm going to come into my intranet, then I'm going to copy the content of this 5main.c file, and I'll put it in my own 5main.c file. I'm just going to paste it in here. So we have created our own test file. It is this file that you're going to use to test the function that you just wrote. If you look into it, you can simply see the function call over here. So the function that you just wrote, more numbers, this is the function that has been called in the 5main.c file. And that is what contains your main function. It's very simple. All right. So let's just exit and save. Let's ls and see the files we have in here now. Now we have the 5main.c file, which I'm going to use to test our function. Wonderful. Now the next thing I want you to pay attention to is the next thing in the terminal of Julian at Ubuntu. All right. I told you this is the username. So now let's see the next thing that happens. Now Julian runs his code. Okay. And he's using the GCC compiler with all these things over here. What do these things mean? The first thing we see here is GCC. that is a GNU's compiler collection. It's simply the C compiler that runs your code. Very simple. The next thing you are seeing here are several flags that are being used to run your code. This -wall, -pedantic, -wero, all these things you see over here are simply flags that will catch errors in your code. Very simple, nothing complicated at all. Alright, now if you come down here and scroll and click on check your code, the checker is going to run and it's going to find out if there are errors in your code or not. Actually, in the background, when the checker is running, the same thing the checker is doing is what all these flags over here do. It's very simple. So these flags work in the background to find errors in your code. But this time around, you are going to do it on your own. The next thing you're going to see is this _putcar.c file which you created, because you're going to need it to output text. Then this is your 5main.c test file which you created. It's all part of the compilation process. Alright, then the next thing you're going to see is the name of your source file, which is 5morenumbers.c. That is the file that we just created. This is it. So 5morenumbers.c. That is your source file which you're about to compile. This is it. And if you go into my intranet, you're going to see that file over here, 5morenumbers.c. That is the file that we are about to compile. And then we are going to tell our compiler that output the executable file that you're going to create to this 5morenumbers file. Now remember that in C programming, when you compile your file, an executable file is created, and that is what you are going to use to run your code. So we are telling the compiler that the executable file, give it this name, 5morenumbers. Alright, and then you're going to output the executable file to 5morenumbers. It's very, very simple and straight to the point. So what you want to do is to copy everything you see over here. So I'm just going to copy that. I'm going to go into my terminal. I'm going to clear my screen. I'll paste the command over here, and as you can see, it's already catching errors for us. This is like the working of the checker. Alright, if you come in here and then you click check your code, you're gonna see some things are gonna be in green and some things are gonna be in red. But here in our case, we are going through that process in the terminal, because in the real world, you are not gonna have the checker to be seeing green and red to know whether your code is correct or wrong. I hope you understand. So what you are seeing over here is that our compilation process is coming up with some errors right in our terminal, and we need to fix these errors. So what you need to do now is to go into the error message, read it, and find out where the error is coming from. It's a very simple process, and for our case over here, we can see that the error is coming from the putcar function. It's saying that it is an implicit function declaration, which means that it cannot be recognized. Alright, and this is simply because we didn't go and put the prototype of our putcar function in our main.h file. So let's go and correct that, and then we are going to run our checker again. This time around, we are running our checker in our terminal. I hope that is very clear. So I'm going to clear my screen. Now I'm going to vi into main.h, go into the insert mode. Then we are going to look for the prototype of our putcar function, which is right here. Then we're going to put it in our file main.h. Great. So I just came in here and I've added the prototype of my function putcar to the main.h file. I'm going to save and exit out of here. Then we are going to run our compiler again. GCC with all the flags, our putcar file, and then we are going to output it to 5morenumbers. So let's run this and see what happens. As you can see, there are no more errors. So the process that we just went through is actually the process of you clicking on the checker and the checker running your code for you. But this time around, you are doing it on your own, because this is what you would do in the real world, and I cannot emphasize that enough. So we're going to ls and see the files we have in here. As you can see, the file, which is the executable file that we are going to use to run our function, has just been created, which is the 5morenumbers. I'm taking you back into the intranet, and you're going to see that the way to execute this file is to use // and then the name of the file. And then when you execute this file, this is the output that we are expected to get. So let's go and run this. I'm just gonna paste it in here and I'm gonna enter. I'm executing my file, and as you can see, the same output that we have in our intranet is the same output that we now have in our terminal. This simply means that your code is working correctly. Without clicking on the checker, we have been able to check that the function that we wrote is working perfectly, and we didn't have to rely on the checker. This is a very important skill that you need to have. But remember that of all the C codes that you write, they also have to be compliant with Betty. So when you actually go into your checker and click on the checker, check your code, the green boxes that come, one of the boxes is to ensure that your code is Betty compliant. All right. So we are just going to go in here. I'm going to clear my screen, and then we are going to Betty name of our file. Okay. 5 more numbers.c. Let's see if our code is Betty compliant. And as you can see, there are no Betty errors over here, meaning that when we click on our checker, when we push to GitHub and check our code, we are not supposed to have any errors because our code is Betty compliant, and also we have used the GCC compiler to ensure that our code has no errors. So as you can see, it says congratulations, all tests passed successfully, and everything is green. All these green things you see over here is actually the process that we went through in our terminal by using the GCC compiler. This, we just entered, created an executable file. Now we executed our file, and then we had the output of our code. Isn't that wonderful? Now let's go and try this on a Python project, and let's see how that too works. Okay guys, so here we are in another great terminal. Now this time around, we are not in Julian's terminal, we are in Guillaume's terminal. So you see Guillaume at Ubuntu. That is the username of the user of this particular terminal that you see over here. And this tag says that you write a function that checks for lowercase character. This is the prototype of the function, returns true if it's a lowercase. So all these are the requirements of the project. That's not our focus for today. Okay, so what we are going to do is that let's go and create the name of this file, and the directory we are supposed to be working in is Python if else blah blah blah. So I already have a directory here. We are just going to work in that. Let's ls and see what's in there. It's empty, so it's not the actual directory, but don't worry, we are just going to use that to work. So I'm just going to vi the name of my file, then I'm quickly going to paste in the code that answers this question. Just going to put it in there. Now if you look at this carefully, you're going to see that this time around the shebang is not a bash shebang. Because we are running a Python script, we're going to need a Python 3 to be able to run our script. So if you look at the shebang carefully, it's user bin, it's not bin bash anymore, it's now bin and Python 3, because it's not a shell script, you're writing a Python script. And that is the code that answers that particular question. So let's save and exit out of here. Lovely. Let me ls. Let's see the file we have in here. We now have the file, our source file that we created. Lovely. Now let's go back into our intranet and let's see how we are going to check this to see if what we have done is correct without the help of the checker. As usual, I'm going to bring you into my gray box. Guillaume is running his codes. If he cuts cat7main.py, this is the content of that file. So to be able to run and check your code, you also need to go and create your own 7main.py file. I'm just going to copy that. I'm going to vi that in my terminal. Now the next thing you want to do is to come into the file, copy the contents of that file, which is going to be used to test your function, and paste it in here. I'm just going to save and exit. Let me clear my screen. This simply means that when you now cat your own 7main.py file, you should see the same content in the terminal of Guillaume. So he cats his 7main file, and we see all these things inside. Now we also cat our 7main.py file, and we see the same content inside. So let me ls, and you're gonna see that we have created, this is our source file, and this is the 7main.py file that we created, and this is the content of that file. It's very simple and straight to the point. Now the next thing you need to do is that remember that this is going to be an executable file, which you're going to execute to check if the function you wrote in this file is correct. So you need to change that file definitely to an executable file, and the way to do that is to change the mode u+x and then the name of your file, which is 7main.py. Now enter. Then the next thing, let me clear my screen. The next thing you want to do is to execute that file, just as you see over here. So Guillaume at Ubuntu executes his file by using // and the name of the executable file. We are also going to do the same thing. So I am also going to use the same command to execute my file, which is 7main.py, and I enter. Now look at the outputs that I get. It says that A is lower, H is upper, G is lower. If you look into my intranet, the same output is over here. So this is a test. These are the tests that were written for the function that we wrote, and this is the outputs that we are getting for these tests that were written. And once again, without relying on the checker, we have been able to check our code correctly, and we don't have to rely on clicking this to find out whether our code is correct or wrong. And as you can see, everything is green, but you didn't have to click on this to find out if everything is green before you knew your code was working correctly. Right in your terminal, you could check if your code is working correctly or not. So guys, this is where we are going to end today. Make sure you hit that subscribe button, because there are a lot more things that I need to be teaching on this channel. So if you have not subscribed to this channel, you are missing out on a lot. Click that subscribe button. There's so much we are going to be learning in the days coming. As always, happy coding.